I needed it till Monday. All right. Okay, so the reason we are doing logarithms in this unit is because it actually, oh, hold on, I want to record. Resume recording. There we go. Aye. All right, so logarithms and exponentials go hand in hand. So we have to be able to switch from logarithmic form to exponential form. Now they're inverses of each other. Just like addition undoes subtraction, division undoes multiplication, and so on. Square roots undo squares. Log bases undo bases. So everybody, this reads. You have to be able to understand how it reads. So this says y equals log to the base a of x. So that's base a of x. Uh-oh, we better switch pens before this just becomes bad news. Okay. Base a of x. So understand that like x is like trapped inside the parentheses. A lot of times they don't write parentheses around the x, but you've got to understand it's trapped inside. So if we were to plug something in, we'd be plugging it in right here. All right, and then this, it reads y equals base a to the x power, which is exponential form, and this is its logarithm form. So notice base a of x raised to the x. So once again, logarithms undo bases, bases undo logarithms. So notice right here that we're not solving anything. It already is a true statement. They're telling us log to the base 2 of 32 equals 5. What I'm asking you to do is rewrite it in its exponential form. So this is how you'll do it. Just think through it as an algebra problem. You would say, okay, I need to undo the logarithm if I want to write it as an exponential, because notice the exponential doesn't have a logarithm. So this is log base 2. Do you all agree? So what undoes a log base 2 is a base 2. So what you're going to do is you're going to do base 2 to both sides of the equation. So base 2 raised to the log base 2 cancels out, because that's what inverses do. So then 32 now is just by itself. We have 32 equals, and then make sure, guys, we said this was base 2. If it's a base, then it's the base and then raised to the 5th power. And look, you guys see how it's a true statement. Here the 5th equals 32. So that's how you can check to see if you've done it right. So now notice, once again, we didn't solve anything. We've just changed it from logarithmic form to exponential form. So looking at this is an exponential equation here. It's telling us the answer, so it just wants us to switch into its logarithm form. Now with this one, what would be the base? 16. Isn't the 16 technically the part that has the 1/2 power? Isn't this a true statement based on like base 16 raised to the 1/2 equals 4? You guys kind of see? Yeah, same thing as the square root, but we would want it as an exponent. This is exponential, you know what I mean? So we're writing it as exponential. So how would we undo base 16? We would log base 16, just like over here. Do you see the opposite? So I'm going to log base 16, both sides. Log base 16. You write the base small, notice? Log base 16. So then right here, log base 16 of base 16 cancels out, and 1/2 drops down. So we have 1/2 is equal to, and then over here, when you take a logarithm, it traps the other side. It's like it's eating it. It's like entrapping it. So we have a log. Oh my heavens, I can't do this today. Log base 16 of 4. True. Okay, sorry, this is a parenthesis. Okay, so are we good with that? We just switched from exponential form to logarithmic form. I need a new smartboard, honestly. Okay, so let's rewrite this in exponential form. What would I do? We're still practicing. Notice it's already a true statement. What would I do? Base 10 both sides, correct? That's what undoes log base 10. So then these cancel out. So then we have 0.1 equals, or 0.1, same thing, equals base 10 to the -1 power. And then you could see, is that a true statement? And then it would be good. Okay, let's rewrite this in its logarithmic form. So we would Log base 10 both sides. Log base 10. Log base 10. So then log base 10 and base 10 cancel out. So 3 drops out. 3 is equal to. And then this is log base 10 of 1,000. Yeah, true. And that is something we'll talk about. Eventually we'll understand that if it's base 10, you don't have to write it. You can just write log. Way to remember that. All right. This is not okay. I don't know how to fix that. Like, I really have no idea. I've like uninstalled the software and then, okay, so start writing these down. Okay, so here are some basic logarithm properties. So some basic ways to simplify logarithms, in other words. Properties help you simplify logarithms. So log to the base a, any base of 1 will always equal 0. Log to any base of 1, if 1 is inside the parentheses, it'll always equal 0. So log to the base 5 of 1 would equal 0. Now here's why, everybody. So why does this rule work? Well, let's think about this. Look at this right here. Look at this truth statement. If I was to rewrite it in exponential form, I would base 5 both sides. So then wouldn't I have base 5, base 5? So I would have 1 is equal to base 5 to the 0 power. You guys see? Well, that's a true statement. Well, now any base I put right there to the 0 power, won't it always simplify to be 1? So if you think about it then, log to any base of 1 will always simplify to be 0. So that's a rule you're going to want to remember. The second rule is super easy, honestly. So log the base a of base a to the first, base a technically to the first power equals 1. Well, that's really easy because we just talked about how log bases and bases undo each other. So do you guys see how these just cancel right out? Log base a and base a, we just talked about how those are inverses of each other. So they cancel out. So that would leave me with a 1. So look, log base 5 of base 5 to the first power, technically. So log base 5 and base 5 would cancel out, and then that would leave us with 1. So log the base of a base raised to the first power will always simplify to be 1. And rule number 3, log base a of base a raised to the x power will always simplify to be x. Can anyone tell me why? Yeah, these cancel out, and then x is all by itself. So log base 5 of base 5 raised to the x power cancels out, and we would just get x. So I mean, these rules are really pretty straightforward, besides this top one, honestly. Right here, base a raised to the log base a of x will equal x, which makes sense. We just talked about how they're inverses, right? So inverses undo each other. So do you guys see how those cancel out? And we get x. So base 2 raised to the log base 2 of x, these would cancel out. They're inverses of each other. So that would be x. So you just got to know those properties to simplify things quickly, basically. Yep. It's basically just simplifying. It's not like actually solving anything. Does that make sense? We're just simplifying. It's like simplifying 2 squared is 4. Same idea. So let's go through these examples. Don't write them down because you're not going to have time. And they simplify like this. So you won't have time to really write them down. Okay? So they should take you 1 second. Log base 2 of 1 equals 0. Log to any base of 1 always equals 0. That was one of our rules, right? All right, log base 5 raised to the 8th power will simplify to be 8. Very good, because these cancel out. Awesome. Right here, base 5 raised to the log base 5 of 12. 12, you're right. These inverses undo each other. Log to the base of half of 1. 0. Okay, good. Log base 2 of base 2 raised to the x minus 2. X minus 2. Don't be that person on the test that then sets it equal to 0 and says x equals 2. We're not solving, we're simplifying. Does everybody see what I'm saying? Don't go and solve it. Okay, so with this one, what would it be? 1, right? Isn't this 3 to the first power right here? So then these undo each other and we get 1. Smiley face, log smiley face of 7. 7. Okay, good. I think we understand that bases undo logarithms to the same base. And log bases undo bases because they're inverses of each other. All right, let's talk about the graph of a logarithm. Everybody, you really need to listen to how I teach you to do this. People have a hard time graphing a logarithm, and they're not hard at all. But I think people forget the steps, so everybody focus really hard on this one. So y equals base 2 to the x is exponential. We learned how to graph that last time. So we know we made an xy chart, and we plugged in some values. -2, -1, 0, 1, and 2, for example. 2 to the -2 is 1/4, isn't it? 0.25. So 2 to the -1, we flip it over the fraction. Do you guys see why I'm getting that? 0.5. Any base to the 0 power is 1. Plug in 1, we get 2. Plug in 2, we get 4. On all exponentials, where was the horizontal asymptote with no shift up or down? 0. We would draw that in, and then we would go ahead and graph it. So then if I plug in 3, what would I get? Because I want to be an exact. My graph wants to be perfect on the test. So do you guys see how 8's on here? I need to make sure I graph all the points perfectly. So if I plug in 3, I get 8, don't I, guys? So over 3 up 8. And then now we can go ahead and connect. So our domain would be all real numbers. We know that's true for all exponentials, no matter what. And then our range on this one, since our asymptote is at 0, it's from 0 to infinity. The only thing that would ever change that on an exponential is a shift up or down. Pretty easy, right? Now guys, isn't it true that this and this are inverses of each other? Well, let's see if they really are. So to find an inverse, don't we switch x and y of an equation? So we have x is equal to, I'm starting here, x is equal to base 2 to the y. And then aren't we trying to solve for y with inverses? That's our next step. So we need to get base 2 to go away. Don't divide by 2. That's not what undoes a base 2. So what are we going to do to undo base 2? Log base 2 both sides. Log base 2. So now look over here. Log base 2 and base 2 cancel out. So we have y equals, and then over here we have log base 2 of x. And then I just write it as y equals. Do you guys see though how they're inverses of each other? Which hopefully from here on out you'll be able to see, look, base 2, they are inverses of each other. Log base 2 and base 2 are inverses of each other without having to do the algebra every time. So now how can anyone remember, if you're given a set of x, y points, if I wanted the inverse of these points, what would I do with them? Switch them. So we literally just take our exponentials x, y points and we just switch them. So now it's 0.25 0.25 -2, it's 0.5 -1, it's 1 0, it's 2 1, and then it's 4 2, and then it's 3 8. Nope, I didn't switch that one right. 8 3, right? My bad. Okay, 8 3. Okay, let's graph these points. So I'm going over to the right 0.25, that's over barely any, and then down 1 2 units. That would put me like right there. I'm going over a half a unit, down 1 unit. I'm going over 1 up 0 units. Over 2 up 1 unit. Over 4 up 2 units. Over 8 up 1 2 3 units. So now connecting those. So can anyone decide, maybe if there was an asymptote on this one, wouldn't it make sense that the inverse would also have an asymptote? Good, yeah, now it's a vertical asymptote at 0 here. Behind a little bit. All right, so what would our domain be? 0 to infinity. Hey. No. Okay, and then what would our range be? Yep, all real numbers. So guys, this was a parent function of a log base 2. So looking at this right here, we know that the domain is from 0 to infinity. This will always be true for all all logarithms that don't have a shift left and right. Wasn't it true that no matter what the base is here, we had a horizontal asymptote of 0? Unless it's up or down shift, right, everybody? All exponentials have this asymptote at 0, no matter what the base is. So log any base of x will have this asymptote as well at 0 here, but it'll be vertical. So the domain will be 0 to infinity, and the range for all logarithms will always be all real numbers. Because picture me taking this parent function and shifting it up or down. You guys see how it would still grow down and up forever? But now if I shift it left and right, that would change our domain, and that would change our vertical asymptote. Do you ever have problems with your pen working?
Yeah.
Well, mine don't work. It's okay. I need a new smartboard. I'll go to Cedar Valley if you'll buy me a new smartboard.
They're buying a new smartboard.
Oh, just kidding. Just kidding.
You didn't think that was going to happen, did you?
No, I did. I figured you probably would. All right. See, look, does yours do this too? Mine lags between each slide.
It's not necessarily the smartboard. That's
Really, you think? So who,
the screen changing?
should I take it to Michael?
I just think, like, smartboard's almost there for reflection. You can but you have.
What do you mean? I've bought, and this is my third smartboard pen. I've purchased my own money for $80 this year. So it should work. All 3 pens don't work. Yes. So, but do you, in your opinion, should I take my computer to someone? Tell them it's kind of slow? Okay. All right, everybody log base 3 of x. Where would the asymptote be? Yep, a vertical asymptote at 0. Now from here, guys, how do we get this logarithm's points? Well, you can't unless you have the exponential's points. So we're not going to graph the exponential, but we're going to use the exponential to get some xy points so we can switch them to get our logarithm points. What would be the exponential inverse of log base 3 of x? Wouldn't it be the same base? Base 3 to the x, right, everybody? It's just that the exponential form has to have the same base. Does that make sense? So then you'd make an xy chart for that. So then plugging in -2, -1, 0, 1, and 2. So if we plug in -2, we get 1/9. Plug in -1, 1/3. Plug in 0, we get 1. Plug in 1, we get 3. Plug in 2, we get 9. Do not plot those points or you'll be plotting the exponentials. We're just using those because now we have our logarithm points. So now we'll switch them. 1/9, -2. 1/3, -1. 1, 0. 3, 1. 9, 2. So then you're just plotting points. You're going to the right 1/9, down 2 units. To the right 1/3, down 1 unit. To the right 1 up 0, over 3 up 1, over 9 up 2. And there is our logarithm. So the domain for all logarithms that have no shift left or right would be 0 to infinity, wouldn't it? And your range for all logarithms is all real numbers. So not hard, but it's just remembering how to do it. People usually kind of get stuck on, they forget where to start, which is rewrite the exponential form of it. Get those points, switch them. Okay, doing good. Okay, so now we're going to add in a shift. Everybody, you got to listen really carefully to this part. So we have y is equal to negative log to the base 2 of x plus 1 minus 2. What we're going to do is we're going to get the parent function's points, then shift the logarithm. So now, looking at this, what would be the parent function of this function here? Just log base 2 of x without all the shifts. You guys see how we took off all the shifts? Now from there, we need the parent function's logarithm points. So wouldn't we use base 2 to the x to get those points? Do you guys see what I'm saying? So then you'll write down some xy points. Then we'll shift the parent function of the logarithm though. Does that make sense? 0.5, plug in 0, we get 1, 1, 2. Oh, I'm going to do 3 as well. Plug in 2, I get 4, plug in 3, I get 8. Now, we're not going to shift the exponential. This isn't our points. We're doing the logarithm. We're taking the logarithm's points and we're shifting them. So now we have the logarithm's parent function points. Here they are. So 0.25, -2, 0.5, -1, 1, 0, 2, 1, 4, 2, 8, 3. Now we have our log base 2 of x's points, and now we're going to shift. So we don't shift till the very end. Because a lot of people, they shift very first. Like with these, I don't know what they do, but they do weird stuff. All right, so let's describe the shift here. This is a reflection over the x-axis, isn't it? A negative in front for all of our functions all year have been a reflection over the x. So doesn't that affect your y values? So you're going to go to your y values and times them by -1. That's what we've done all year with all the different types of functions. Then we're going down 2 units. So then after that, we'll subtract 2. Thanks. And then we're going what? Yeah, good. Left 1. So we'll be subtracting 1 from our x's. Now the first thing I'm going to do, guys, is go draw in, before I even write in the xy points, I guess, I'm going to go put in my new asymptote. Where should it be? Remember, logarithms have vertical asymptotes. Add 0. So where will it be now? -1, because we went left 1. You guys are awesome, by the way. Seriously, you are. Okay, so let's write down our official new xy points, and then we'll just plot points. 0.25 minus 1, isn't that -0.75? And then 0.5 minus 1 is -0.5. 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 1 is 3. 8 minus 1 is 7. 2 times -1 is 2. And then minus 2 would be 0. -1 times -1 is 1. Minus 2 is -1, isn't it? 0 times -1 is 0. Minus 2 is -2. 1 times -1 is -1. Minus 2 is -3. 2 times -1 is -2. Minus 2 is -4. And then last, 3 times -1 is -3. Minus 2 is -5, isn't it? Okay. So let's graph those points, and it should be close to your asymptote. So we're going back 0.750 over -0.5 up 1. Sorry, it's kind of hard to draw these perfectly. Over 0, down 2 units. Oh, I went up 1, didn't I? So over -0.750 over -0.5 down 1. Over 0 down 2, over 1 down 3, over 3 down 7, was that what it was? Oh, down 4. Over 3 down 4, and then over 7 down 1, 2, 3, 4, 5. Can you guys see what's happening? I can definitely see, we know it's approaching the asymptote. Now don't be the person that goes, oh, it stops right there. No, it doesn't. It continues by the asymptote. We just don't have enough points to show that, but we know how asymptotes work. So our domain would be, yep, -1 to infinity. And then our range would still be -infinity to infinity, wouldn't it? All right. So do you guys feel pretty confident graphing a shifted logarithm? Okay. So I'll see here. We don't have to do this one if you don't want. It's up to you guys. This is a reflection over the y-axis. Okay, so let's just talk about the steps. What steps would we take? We'd start with base 2 to the x. We would get those xy points. Then we would do what? We'd switch them, correct, to get our log base 2 points. So we would have our official logarithm points, right? And then what would we do? It says a reflection over the y-axis. So wouldn't we times our x's by -1? And if you think about it then, where is my asymptote at? Was there any shift left or right? So it's still at 0. And now normally a logarithm looks like this. I'm going to do a rough sketch if you don't mind. So normally a log would look like this, but it's reflected over the y-axis. So now it's just going to look like this. But it'll all work out. So our domain this time is negative infinity up to 0, isn't it? But our range is still all real numbers. For all logarithms, no matter what, the range will always be all real numbers. You guys are doing really good. Okay, once again, just tell me the steps you would take if you don't want me to graph it. You'd start with a base 10 to the x. You would write down those xy points. You would switch them, and that would be your official logarithm's parent function, right? Then we would add 3 to our x's. So we would be at positive 3 would be our asymptote, and then I'm going to do a rough sketch. It would look something like this, wouldn't it? There was no other transformation. So our domain would be now 3 to infinity, but our range would be all real numbers still. Okay. All right. So just a couple things to note. Just like with a square root, there's technically not a 2 there. There's not a 2 there, but there technically is what I should say, right? There really is a secret 2 there. We have to just know this. Log base 10 of x will not be written as base 10 normally. They're just going to leave it blank. So you just have to know when you see log to the blank base that it is base 10. Just like when we see a square root, there's nothing there. We know there's a 2 there. So everybody, blank base means base 10. Now, log base e, remember e is not a variable. E is approximately 2.7. So instead of them writing log to the 2.7, they could write log to the base e of x. But log base e, they don't want to write it as log base e. So just like base e is just a special symbol for 2.7 roughly, they will write, instead of log base e, they'll write ln. So guys, ln and e are inverses of each other. ln and e are inverses of each other. They get their own special little logarithm and base. So what undoes base e? Ln. What undoes ln? Base e. So then all the properties we just learned a second ago, these are all, you don't need to write them down. These are the same properties of logs we just learned. Bases undo logarithms and logarithms undo bases, correct? Now, didn't we just learn log of any base of 1 will always simplify to be 0? A couple minutes ago. And then ln and e, what would that simplify to be? 1. Isn't this to the 1 right here? And then they cancel out. So ln of e to the x would simplify to be x. E raised to the ln of x would simplify to be x because inverses undo each other. So let's practice. Ln of 1 is 0, right, everyone? Log of any base of 1 is 0. You're fine. Ln of e squared, 2. Ln of e to the x minus 2. X minus 2. Ln e raised to the ln of 75. 75, because their inverses undo each other. Okay, so if you're asked to graph an ln function, guys, what you would do is you would, on your calculator, even your doinky little calculators, you have the e button. So you would go, you might even have an ln button. Then you don't even have to do it by inverses. Couldn't you just plot some points, plug in some points? Does everybody have ln on their calculator? Okay, if you didn't though, you would do base e to the x. You would write down those xy points, and then wouldn't you just switch them? But you guys all have an ln button on your calculator most likely, so you could literally just plug it. Oh, can it be negative inside a logarithm? No, because if you think about it, don't our asymptote start here at 0? So I wouldn't do -2. If you do, it'll say error. You tried -1, it'll say error. What's ln of 0 without the calculator? Right, 1, isn't it? Oh no, that's not. I'm backwards. It's ln of 1 is 0. My bad. Can I look right here? Look at our vertical asymptote. Do you guys see how it's at 0? So can we plug in 0? Do you guys see? Do we ever cross vertical asymptotes? No. My bad. Sorry. That rule is backwards in my head. If I plug in 1, though, we get 0. That's not true. Yeah. If I plug in 1, what decimal do I get? ln of 1? Point what? Yeah. No, sorry. ln of 2. My bad. Sorry. Next point. Point what? 0.6. Okay. 6.9. Let's plug in 1 more at least. Thanks. So looking at this, plotting points. Look, so I went over 1 of 0, over 2 up 0.69. I didn't do that very good at all. It's right there, but it's not bad. And then over 3 of 1.09. I think that's maybe, I don't know what. I maybe just do a rough sketch, but it looks about right. Okay, so what would the domain be? Yep, 0 to infinity. And my range would be all real numbers. So the only thing that would change this is if we shift it left and right, the ln left and right. So let's look here. Just state the domain of the logarithm. This is going to be part of the homework. This should be the easiest part for us. For a logarithm, what matters is a shift left or right. I'll be right with you. I'm sorry, I just can't stop my life. So shifts left and right, correct? That's what matters for a logarithm. What matters for an exponential? Shifts up or down, which would affect our range. Okay, just making sure. So right here, we're shifting left 1. So then our domain would be -1 to infinity. Does everybody see? Okay, right here. Right 2. Now, even though it's up 1, that doesn't affect anything, correct? So then you would say your domain is 2 to infinity.
Just for reminders that the FFA is providing breakfast.
7 to infinity, because it was right 7. Do you all see? And left 2, so this would be -2 to infinity. Now they're not all going to be quite that straightforward. Like, let's look at this one. Everybody, I would write this down in my notes. This is going to be a more advanced domain. Now here's the thing, guys. We know with logarithms, we have vertical asymptotes right here at 0. So our input, what we plug in, has to be greater than 0. Do you agree? So isn't my true statement what's inside here, 4 minus x squared, will have to be, that's my input, do you agree? Will have to be greater than 0. Can it be equal to 0? No, because we have a vertical asymptote. So with this one's domain, we can't just do the shift left or right because it's a little bit more advanced inside. You guys kind of see? Then now we're solving, if you can recall, a quadratic inequality. So what I would do is, remember this is actually how we solve quadratic inequality. We factor it, we find the zeros, we have to make a number line and do yes, no, yeses. So let's hurry and factor this. Can anyone tell me what this would factor to be? X plus 2? X minus 2 is greater than 0. So my two zeros are x equals -2, x equals 2. So you would hurry to find your domain, you would make a number line, put in a -2, put in a 2, and then start testing values. So let's plug in a value in the middle, because remember, it'll always bounce, won't it? So if I know the middle, I know the rest. So let's plug in 0, everybody. So I plug in 0, that would be 0 plus 2 times 0 minus 2 is greater than 0. So isn't that 2 times -2 is greater than 0? -4 is greater than 0? Nope. So that is not in our domain because it was not a true statement. So then it must be yes, and it must be yes. So now we can see by this picture our domain, we've got to write it in interval notation. So you would say -infinity up to -2, not including -2, union 2 to infinity. So just a reminder, if you're dealing with domains of logarithms, if it's anything other than a shift left or right, you've got to go through and do this. If it's quadratic. Now what if it is not just 1, like this one? Y is equal to ln of x minus ln of x plus 3. Yep. Yes, do it for both, and then you got to merge it together. So isn't it true that right here my domain is 0 to infinity, isn't it, guys? Logarithms have asymptotes at 0 unless there's a shift left or right. What's my true statement here? Sorry, -3 to infinity would be my domain. Agreed? Now, I think a lot of you actually have this backwards in your head. You think you need to make it so, like you combine them in the wrong way. You have to go with the most restrictive answer. Can you plug in negatives into this one? No, so you can't, even though you can plug in negatives to this one, you can't this one, and you can't pick and choose. If you plug in a negative, it's going in both. So you've got to go with the most restrictive answer. Does that make sense, everybody? A lot of people go with the least restrictive because then it combines all the domains together, but that's backwards to kind of thinking. So what would my official domain be? 0 to infinity. Because that works over here, doesn't it? And it works over here. So it's just got to work for both. Go with the most restrictive domain. Okay, just tell me how you do this one. We won't do it, but I want you to tell me how you do it. X squared plus 3x is greater than 0. You would factor, find the zeros, test yes, no, yeses. All right, we're down to our last couple. We have 2 last examples. I just felt like if I didn't show these last 2, you might have a hard time doing it. So let's look at this. Write the equation of the logarithm that fits this graph. So they would just give you this graph. So first of all, notice there are no shifts left or right, correct? So we got to fill in the dots here. We want it to be y equals log. It's obviously a logarithm. Log to the we don't know of x. Does everybody see? You got to have of x because that was what makes this an equation. All we have to figure out is what is this base. So what I did was I went to here and wrote down the official points of the logarithm. So 1, 0 was a point and 9, 2. Do you guys see? Now, to me, then after that, I thought it was easier to look at this as an exponential. So what do? You switch them. So here are our exponential points. If we plugged in 0, we get out 1. If we plug in 2, we get out 9. What base raised to a power will make this a true statement? Raised to the x. If you plug in 2, it would be base 3, correct, everybody? Base 3 squared would be 9. There's a more algebraic way approach for this, but honestly, I felt like just thinking about it would be the easiest rather than getting into that whole algebra of it. You guys see why Axel said base 3? So what would the base be here? 3. So that's your answer. Log base 3 of x. And then you could check to make sure it works. Want one more like that? Okay. All right, so 86, let's read this. A spectrophometer measures the concentration of samples dissolved in water by shining a light through it and recording the amount of light that emerges. For a certain substance, the concentration is found by using this formula. Remember, we're not going to get scared away by story problems. We haven't had any hard ones. They've all been plug and chug. It says, find the concentration of the substance if the intensity I is 70%. Maybe I didn't finish writing that down. What the heck? Find the concentration of the substance, that would be C, if the intensity I is 70%. Oh, no. Oh, it's 70% of I naught, or of I zero, or I sub 0. Sorry, that's how they say it in calculus, I naught. All right, we can do that. All right, so I is 70% of I naught. How would we write that in there? That's kind of a weird one. C is equal to negative 2, 5, 0, 0, ln of, we need I to be 70% of I naught. How could we write I over I naught? So that it's 70%. 7 over 10. You guys see why she said that? Yeah, I said that I is 70% of I naught, so 7 out of 10. Does that make sense? I'd make it 70%. Or you could even write 0.70 right here. Because how do we find percent? You divide. If that makes sense. So that one was kind of tricky. 7 out of 10, or 0.7. And then from there it said find the concentration. That's why I knew I was just finding C. So then you just plug it into your calculator. So you would just type it right in because you all have an ln button on your calculator. What do you get? Let's just see real quick for the video, Axel. And then this is the last slide of the lesson. $391.68. Thank you. All right, that's the end of the lesson. So luckily next week, everybody, the good news